Alright, so today our lesson is going to cover rhombuses, rectangles, and squares. These are the special parallelograms that I was talking about in our previous video. Okay, now all of these have opposite sides parallel, and that means that they follow all the same rules. Opposite angles must be congruent. Okay, they have that the consecutive angles must be supplementary, the diagonals bisect each other. They all have the same properties as a parallelogram because they already are a parallelogram. They just have a little something extra that the parallelograms are missing. So in the case of the rhombus, not only are opposite sides congruent, but in fact all four sides must be congruent. That's what makes a rhombus different from a parallelogram. Now with a rectangle, we know the opposite angles are congruent. In this case, if they're 90 degrees, then all four must be 90 degrees because the consecutive angles are supplementary. So that's what makes a rectangle different from a parallelogram. Now, if you imagine that it was mommy rhombus and daddy rectangle, then the square is born. It has its dad's angles, all right angles, and it has its mother's sides, all four sides congruent. Okay? So a square it also takes on the properties of a rhombus and a rectangle as well as a parallelogram. Okay? So if you take a look at this Venn diagram, everything in yellow here is a parallelogram. This whole box and everything in it is a parallelogram. However, sometimes we have special properties like a rhombus where all four sides are the same length. Okay, so all three of these are considered rhombuses. Now, on this side we have rectangles because all of their angles are 90 degrees. So showing that here, 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 and here. This one has also got all four angles 90 degrees. So do you notice that a square is both a rhombus and a rectangle? And every one of these five are also parallelograms. Okay? So taking a look at the same Venn diagram, we need to determine if the statement is always, sometimes, or never true. Is a rhombus a rectangle? So looking here at this blue box, will any of these three rhombuses ever become a rectangle? And the answer is yes, this square. So sometimes this is true. It's sometimes when all the angles are 90 degrees when you have a square. Alright, a parallelogram is a rectangle, okay? Looking at this whole box and everything in it is a parallelogram. Occasionally we will have rectangles, and these three options here are the three rectangles. So this would be a sometimes. A square is a rectangle. Can you ever draw a square that does not have all the angles 90 degrees, like a rectangle? And the answer to that is no, you can't. So a square will always have to be a rectangle. Oops, if I could spell. Alright, and is a rectangle a square? Well, this rectangle is not a square. This rectangle is. So that would have to be sometimes, and that's only when the rectangle has all four sides the same length. Alright, so using the properties of special parallelograms, it says that ABCD is a rhombus. Whoops, sorry guys, I did not realize I had my phone on loud. That is a Kim Possible theme song, or her Communicator. I don't know if you ever guys watched that show growing up, but I'm going to put my phone on silent. Oops, sorry guys. Still not. Quit texting me, people. Alright, there. Now it's on silent. We should be good to go. Who knows? Maybe we'll throw that little mistake in as a pop quiz for tomorrow. Kim Possible, guys. Good show if you've ever seen it. Anyways, so it says ABCD is a rhombus. What else do you know? Well, ABCD has four congruent sides. So this side, this side, this side, and this side all have to be the same. That's definition of rhombus. We also know that the opposite sides are parallel. And the reason we know they're parallel is because a rhombus is already a parallelogram. So don't opposite sides have to be parallel? Opposite angles are congruent because it's a parallelogram and it follows the same properties. So congruent, 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 congruent. Its diagonals also bisect each other. That's the same thing. That's coming from your parallelogram properties from the last video. Consecutive angles must be supplementary. So if you take a look at this, all of these come from your properties of parallelograms, don't they? So the only thing different about it, the only thing different about it is that it has 4 congruent sides instead of 2 pairs of opposite sides being congruent. Okay, so you're going to have to just remember those properties of parallelograms. You're going to have to memorize them because they're going to apply to all the ones that we're talking about today as well. All right, now in this particular diagram it says it's a rectangle, and what's special about a rectangle is that all the angles are 90 degrees. So if angle G is 90 degrees, because they are all right angles, then I can set 7y plus 6 equal to 90 degrees. So by subtracting 6 from both sides, we get 7y equals 84. Divide each side by 7, y equals 12. You can always plug that back in, make sure you did it correctly. 7 times 12 plus 6 equals 90 degrees, and you are correct. Alright, so let's do a couple more examples. The question is sometimes, always, or never true. Number 1, a rhombus is a square. Okay, so I go back and look at my Venn diagram, and I have some rhombuses. That's not a square, but that one is. So I would say sometimes it is a rhombus, or it is a square. Sometimes a rhombus can be a square. Is a parallelogram a rectangle? So going back to that Venn diagram, I got a parallelogram, and then a parallelogram, but only this one is a rectangle. So I would say sometimes as well. Alright, now it says QRST is a square. What is the value of x? Because a square has all 4 sides equal measure, I can set x plus 27 equal to 13 minus 6x. Let's go ahead and add 6x to both sides. And subtract 27. 7x equals negative 14. Divide by 2. X equals negative 2. Alright, let's discuss a few more theorems. Okay, with a rhombus, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So we already know that the rhombus has opposite sides parallel, opposite angles congruent. We know all of the properties listed here. Okay? But we're going to add a few more. We also know the diagonals meet at a right angle. Okay, now because the square is also a rhombus, this applies to the square too. Because the square is just a special type of rhombus, isn't it? A square is a rhombus, just with right angles. Alright, now here's a rhombus again. Now the diagonals are not only perpendicular, but it actually cuts the angles in half. It's an angle bisector. So, and remember that this applies to the square as well, because the square is a rhombus, just with 90-degree angles. Alright, and then let's talk about the rectangle. Okay, so none of that applies to the rectangle. However, the diagonals are going to be congruent in length if it's a rectangle, meaning that AC and BD are the same length. Now this also applies to the square. Because the square is the rectangle, it's just with all 4 sides the same length. Alright, so let's discuss. In this picture, PQRS is a rhombus. Remember, rhombus has all 4 sides congruent, so I can set 2y plus 3 equal to 5y minus 6. What is the value of y? So subtract 2y from both sides. Add 6. I get y equals 3 when I divide by 3. right, the diagonals of a rhombus are always congruent. Now your answers here are going to be true or false. The diagonals of a rhombus are always congruent. The answer to this is actually false. Okay, the diagonals of a rectangle are always congruent, right? So we have to go back and look here. Diagonals are congruent if it's a rectangle, not a rhombus, okay? So that's how we would fix this to make this a true statement. The diagonals of a square are never perpendicular, and the fact is that is false. They are always perpendicular. So if we go back and look, diagonals are perpendicular in a rhombus, and this also applies to the square because the square is a rhombus. So the diagonals of a square must always be perpendicular. So if we cross out never and make it always, then we will make this a true statement. Alright, each diagonal of a rectangle sometimes bisects the pair of opposite angles. Alright, that is actually true. Okay, so we know that the diagonals of a rectangle don't bisect the angles, but we know it happens when it's in a rhombus and a square. And isn't the square just a special type of rectangle? So the answer to this is true when the rectangle is a square. Alright, so that's all we have today over rhombuses, rectangles, and squares. I will see you guys later.